Now we are going to implement the decision tree, and the decision tree, to train the decision tree model, we are going to use the training function, and we already know what the training function does. It basically uses to train the model. And for decision tree, we have some parameters here. The main difference between each model is the parameter that we have for it in the training process. So I call this model decision tree model. I'll use the training function. So what is L1, LL5 is, so we can go back here and see what the LL5 is, because we are going to use the train control here. This is the train control, so that's why I again use the LL5. We saw how to use this LL5 somewhere in our first model, which was I don't remember, I think it was random forest. So LL5, so this function, I can simply copy this expression here and bring it down there, so we can use it easily. So copy. Okay, we explain, we give some explanation about these parameters previously for our first model, so I'm not going to go back again and describe that. We assume that we are familiar with what that parameter is doing. So this is LL5. So to use the train control, we explained already in the first model how to use this train control and why we use it. So we are just going to use it here for the decision tree. So for decision tree, in the training process, I use y. Again, I want to predict y based on all the explanatory variable. My data set is the training data set. The method is R part. So this is the method that determine what you are training, because this R part make me know that I'm using the decision tree. So this is the specific parameter for decision tree, and the parameter is listed. You want to split based on the information. So if you look at the training function, you're going to see this parameter PARMS. So you list and you split based on the information. The TR control is the train control. We know that the TR control take a parameter, take as a function the train control, and we specify this function. You can use different function here. We notice that we use the random here. You can also use a different function. I don't remember, but you can go back and check on the first video on the, I think it was on the random forest. So you use a random here, and the pre-process you use a scale. The tune length you can use a 7. You can use different tune length for this. So that's how you train the decision tree model. The main parameter is the R part. This stands for decision tree. You use this for decision tree model. And the train control, we use it to show how to manipulate the train control function over there. So you can replace different train control function and get different results and see which one had the better accuracy. But I chose to use this particular one with this parameter as a setting. So let us run the model. Something's wrong here. Okay, let me run again and see what happened. Then again, okay, then I set the seed, then I run. Okay, now it's fine. I think this function was missing, this LL5 was missing. Now, so basically I assigned this LL5 to L, and this L is the TR control. So I should have just copied this. I can just copy this. I think it's even simple this way. I can just remove this, remove this. This is a lot of code for no reason. And then just copy this expression, or cut this, then paste it here. It's the same thing. And paste. Okay, so let us train again and see what we have. Then you have a question mark here. Okay, I can run again. Now it's fine, it's training, it's ready. So you can predict using the same technique. This will allow us to predict. So predict, but I want to predict the y. I explained earlier how why we need this one. Let's run this first. So the predict, this I want to try and find the predicted value. I use the predict function. The model is a decision tree model. The new data set is a subset. We saw it described this already. So I want to take the training set, but I want to exclude the response variable so that I can predict the new response variable. When I run this, and you can take a look at this parameter that this expression, you can tell that it gives us it's a categorical variable. Now so this is our y predicted value, but if I want the probability, for instance, you can see that you have only two categories here, 0 and 1. That's why you see the two level is categorical variable. Now if I want to predict the probability, let us remove the 1 first. Then if I run this again, you can tell that we have a two response here. It's the same thing that I described earlier. This is basically the probability of predicting 1 and the probability of predicting 0. But we are interested on the probability of predicting 1 because we are going to use this to construct a single model. So this is the probability of predicting 1 and it's the probability of predicting 0. So I want this probability, that's why I use this sign. That's why I use this $sign. Then I put this code and I'll get the 1. So if I run this now again with this one, and if I run again, I try to check this, what we have in this one, this expression, you will see that we only have okay, now you see that we have only one result, not so this is this expression. Okay, let me check. So we have a 41. If I try to, let's say I do head of this expression, head of this, okay, so we have the first element is 0, 14, 44. Let us check here. Zero 14 44, and so basically we extract only this expression, this information, using the $sign and 1. So we get the probability. This gives us the probability of predicting only 1. Probability of on the testing set. So that's the probability of predicting only 1. Now if I run this, I can get the probability of predicting 1 on the training set. Now I'm not going to use this here, but we're going to use it later on to combine the model. So basically what we are using in this case, this is the predicted value. This is what we really want to predict for this particular model. So this is the predicted value on the testing set, which is the expression. Now you can combine okay, now we apply the same technique. We find the mean, we combine, we check, we compare the predicted value and the original value on the training set. That gives us the accuracy, which is 0.79. And now you can also get the confusion matrix, the same technique. Your predicted value, the original value, and you use the function confusion matrix, and this will give you the confusion matrix here. And we had the same information here: the miscalculation rate, the accuracy, the confidence interval, the sensitivity, the specificity, and so on. So that's how to use the training set. Now you can use the testing set. The testing set, you use the same technique. You use the predict function. We use the same model, but the only difference, we change the data set to the testing set. So we only change the data set to the testing set, and we run again. You can see that the prediction here, the accuracy is 70. So one thing to notice is when you try to predict using the testing set, you are more likely to have a lower prediction rate for the testing than on the training set. So that's something to notice. And I think we are done for the logistic regression, and we are going to for decision tree. So the next one, we are going to see how to implement the logistic regression model. Thank you, and see you on the next video.